Hello friends, here in this video we will see the terminology of helical compression spring. Right? Here many terminologies like solid length, it is denoted by LS, free length, it is denoted by LF, spring index, spring stiffness, pitch, inactive coil and active coil. Right? So we will see one by one the terminologies like first one is a solid length, right? Before that, first we have to see this figure of the terminology of helical compression spring, right? Okay, solid length. What is solid length? Okay, in this figure three types of figure: free length, compressed length and solid length, right? So last one is a solid length. Okay, so the define is when the spring is compressed until the coils touch each other, right? The spring is compressed means fully compressed until the coils touch each other. Okay, all the coils are touching each other, right? It is said to be the solid, right? It is said to be a solid. Then the length of such solid length, the length of such solid length, it is known as the solid length, right? So the equation of the solid length is solid length LS is equal to N dash into D. Okay, now what is N dash and what is small d? Okay, LS means, we know that LS means the solid length. LS is equal to solid length of spring. Okay, N dash means the total number of coils or turns. Suppose this one is turn 1 2 3 4 5 6 7 etc, right? So this one is N dash. Okay, and D means the diameter of the wire, and it is in mm. Okay, diameter of wire means this one. Okay, so the solid length is, it is compressed until the coils touch each other, all the coils are touching each other, and it is said to be a solid, right? And this, at that time, this length is called as solid length, right? And this one is the equation of solid length, right? So solid length. Next one is free length. Okay, what is free length? Then from the figure, this length, right? A free length of the compression spring, right? Free length of the compression spring is the length when the spring is in uncompressed condition, right? Means on the spring no load is acting on the spring. At that time this length is called as the free length, right? And the equation of free length is LF. Free length is solid length plus maximum deflection or compression plus total clearance coil in compressed condition, right? The equation of the solid length, free length is solid length means this length plus maximum deflection means this delta max, right? Plus total clearance in compressed condition, that means this one is the clearance, means this one plus this one plus this one, it is called a free length, right? So the equation of the free length is LF is equal to LS. Okay, sorry, plus maximum deflection, that means delta max, plus clearance between the coil. Okay, that is the simple equation. LS means solid length plus delta max plus clearance between the coil, right? So that's why N dash into D means the solid length, right, plus delta max plus 0.15 delta max. Because of why? Okay, I will explain. Okay, the clearance between two adjacent coils. Okay, the clearance between two adjacent coil in compressed condition, like second figure, okay, is generally taken as 0.5 to 1 mm, right? 0.5 to 1 mm. But sometimes the total clearance between the coil is compressed condition is taken as 15% of the maximum deflection. 15% of the maximum deflection, that means 0.15 delta max. So that's why we have to take 0.15 delta max, the clearance between the coils in the compressed condition, right? So this one is the free length, free length. Clear? Next one is third one, spring index. Okay, this one is first solid length, second one is free length, and third one is spring index. Okay, what is spring index? So the ratio of mean coil diameter, that means what? Mean coil diameter to the wire diameter. The ratio of mean coil diameter to the wire diameter is called as spring index. That means mean coil diameter, that means this capital D, and the wire diameter means small d. So the ratio of capital D to the small d is called as spring index. And the equation of the spring index, C is equal to capital D by small d. That means mean coil diameter to the wire diameter, right? Okay, now small c means spring index, okay, where D means mean coil diameter, already mentioned mean coil diameter, and small d means wire diameter. Okay, these both are in mm. And generally the spring index C is taken in the range of 6 to 12, right? 6 to 12, generally taken as 6 to 12. Okay, so generally spring index C is taken as range, means in between 6 to 12, right? Remember this. Clear? Spring index, the ratio of mean coil diameter to the wire diameter is called a spring index, and the equation of spring index C is equal to capital D upon small d. Okay, next one is spring stiffness. Next one is fourth one, spring stiffness. Okay, what is spring stiffness? Spring stiffness is defined as the load required per unit deflection, right, is defined as load required per unit deflection, right, of the spring, and it is also called as spring rate or spring constant. Okay, it's all are same. Spring stiffness, spring rate or spring constant, all are same, and it is defined as the load required per unit deflection. Okay, and it is denoted by K, right? So that's why spring stiffness K is equal to load required, that means capital F upon unit deflection. Deflection means delta. Okay, right, when the K is, where K is equal to spring stiffness. Okay, okay, in terms of Newton per mm. Why? F is equal to axial force in terms of Newton, and deflection delta, deflection of spring in terms of mm. So that's why Newton per mm. Clear? Okay, spring stiffness is load required per unit deflection, and the equation of K is equal to F upon delta, Newton per mm, right? Next one is pitch. Okay, spring index, spring stiffness, and next one is pitch, right? What is pitch? Okay, let's see the figure. Okay, pitch is the axial distance between, axial distance means this one, right? Pitch is the axial distance between adjacent coils in uncompressed condition. Suppose this one is an uncompressed condition, right? And at that condition, the wire diameter D to wire diameter D, but in consecutive condition, right? So that's why the definition of the pitch is axial distance between, means the parallel to the axis, axial distance between the adjacent coil in uncompressed condition is called as pitch, right? So an axial distance between adjacent coil in uncompressed condition, right? It is called as pitch. It's so simple, right? Next one is inactive coil. What is inactive coil? Okay, suppose we have a spring. Okay, this one is a one type of spring. Okay, listen, suppose this one is a helical compression spring, right? When the end of the coil, means this one, this portion, suppose I can draw this figure, and then after, okay, this one is the figure of the spring, helical compression spring, right? Simple figure. When the end coils, means this coils, end coils which are in contact with the seat, suppose this one is contact with seat, means this point is touched to the seat, right? Do not contribute to the spring action. Okay, that means we apply the force. Okay, now this point to this point, okay, is compressed, means the gap between two consecutive coils is decreased, but this coil is already touched to each other, right? So that's why they do not contribute to the spring action. Okay, so this type of spring is called as inactive coil, right? Suppose we can applying the force. Suppose here is the seat. Now applying the force. Okay, so this coil is compressed here to here portion, and these are touch each other, so they do not contribute to the spring action. Okay, so this spring is called as, this coil is called as inactive coil, right? So the definition is, in helical compression spring, when the end of the coil, when the end of coils which are in contact, which are in contact with the seat and do not contribute to the spring action, right? Do not contribute to the spring action are termed as an inactive coil. Okay, understand? Okay, next and last one is active coil. 7, active coil, right? Okay, in helical spring, okay, same concept. Suppose this one is the spring, helical, the coil other than inactive coil. Suppose we already seen that these are inactive and other than inactive coil is active coil. So this point to this point is this coil to this coil, it is called active coil, right? Which is contribute to the spring action. Okay, which is contribute to the spring action are termed as active coil. Okay, so the definition is, in helical spring, right, the coil other than inactive coil, other than inactive coil which contribute to the spring action are termed as active coil. Okay, understand? In helical spring, the coil other than inactive coil which contribute to the spring action are termed as active coil. And point to be noted, the only active coils, okay, only active coils contribute to the spring action, right? Only active coils are contribute to the spring action, right? Okay, these are the terminology of the helical compression spring. Okay, solid spring, solid length, free length, spring index, spring stiffness, pitch, inactive coil and active coil, right? Thank you.